today's class, we will solve a few more problem sums based on number systems which are of level 1. In the first problem, we have to mention the steps involved in converting this 0.37 bar, means this recurring number, into p by q form, means into a rational number form, where definitely q is not equal to 0. And we have to arrange the steps in sequential order. So in the first step, what we will do is we will assume that the number is equal to x. So 0.37 bar. So here these two digits 3 and 7 will be repeated. In the second step, what we will do is we will multiply both the sides of the equation that we have written in the first step by 100. And why 100? 100 means 10 square or 10 to the power 2, and the power of 10 is decided by the number of digits that is getting repeated. And here, since 3 and 7 both the digits are getting repeated, so the periodicity is 2 and the power of 10 will be also 2. In the third step, what we will do is we will subtract the equation that we have written in the first step from the equation that we have written in the second step. So it will be 99x, and from the right hand side it will be 37. The digits after the decimal point will be cancelled out. So from here the value of x that we will get is 37 divided by 99. And what was x? X was basically the number or the recurring number that we had. So we can say that 0.37 bar, this repeating or recurring number, is equal to 37 upon 99, and that is actually a rational number. Now this type of problem we can also solve by using formula or by using shortcut trick, and that formula is a minus b divided by 10 to the power p minus 10 to the power q, where a is the whole number that we obtain by writing the digits in order. That means without the decimal point and without repetition. Here the given number was 0.37 bar, so the digits were 3 and 7. So the whole number will be 37 or 37. B is the whole number that we obtain by writing the non-recurring digits. Now in this given number, both the digits 3 and 7 are recurring digits. That means there is no non-recurring digit in the given number. So the whole number that we will obtain will be 0. And that will be divided by 10 to the power p, where p is the total number of digits that we have in that given number after decimal point. So here in the given number after decimal point we have only two digits, 3 and 7. So here the power of 10 will be 2, or the value of p will be 2, then minus 10 to the power q. And q is total number of non-recurring digits that we have in that given number after decimal point. And since in this given number after decimal point there is no non-recurring digit, so here the value of q will be 0. So finally the number or the rational number that we will get is, the numerator will be 37 and the denominator will be 10 to the power 2 means 100, and 10 to the power 0 means 1. So 100 minus 1, it will be 99. Now in this second problem also we have to mention the steps involved in converting this given recurring number into its equivalent rational number. Now the number here is a bit different from the previous one. Here before decimal point we have a non-zero digit, and after decimal point we have two digits, among which one is non-recurring and the other one is recurring. So while converting, what we will do is, in the first step again we will assume that recurring number as x, so 1.43 bar. So it will be 1.43, then 3 will be repeated. So this will be our first equation. And in the second step what we will do is we will first evaluate the periodicity of that given number. We can see here only 3, that digit gets repeated. So here only one digit gets repeated, so the periodicity is 1. So we will multiply both the sides of the equation that we have written in the first step by 10 to the power 1. In the third step what we will do is we will subtract the equation that we have written in the first step from the equation that we have written in the second step. So after subtraction this will be 12.9, and on the left side it will be 9x. So from here, what will be the value of x? X will be 12.9 divided by 9. But still what we have in the numerator, that is a decimal number. So we have to convert that decimal number in the numerator to a whole number, and for doing that we have to multiply both the numerator and denominator by 10. So finally it will be 12,129 divided by 90. Now if we apply the shortcut trick or direct formula, then as we know, it is a minus b divided by 10 to the power p minus 10 to the power q. And what is a? A is the whole number that we obtain by writing all the digits of the given number. So here what are the digits in the given number? 1, 4, 3. So that will be the whole number which will be represented by a. And what is b? B is the whole number that we obtain by writing all the non-recurring digits. So in that given number, non-recurring digits are 1 and 4. So here the value of b will be 14 divided by 10 to the power p. And what is p? P is the total number of digits in that given number after decimal point. So here after decimal point we have only 2 digits. So here the power of 10 will be 2. I mean the value of p will be 2. And then from there we will subtract into the power q. And q is total number of non-recurring digits that we have in that given number after decimal point. So here in that given number we have only one digit after decimal point, which is 4. So here the power of 10 will be 1. I mean the value of q will be 1. So finally it will be 143 minus 14. So it will be 129, and divided by, in the denominator we will have 100 minus 10. So it will be 90, which is in this format p divided by q. Now in this problem sum we have to find the value of x, where we have an equation where the value of x square is given, which is 6.25. So in the first step we will write that equation which is given. In the second step we will represent that decimal number by a rational number. So it will be 625 divided by 100, as after decimal point we have only 2 digits, so 10 square. Now in the third step what we will do, we will represent both the numerator and denominator as perfect square. So 625 means it is a square value of 25, and 100 is square value of 10. So finally it can be written as 25 divided by 10 and then square of that value. So till the third step we have the equation where we have the square value of x, and in the last step what we can do, we can take the square root of both the sides of that given equation. So the left hand side will become x and the right hand side will become 25 by 10. Now 25 by 10 is a rational number, and if we want to convert that to a decimal number, then it will be 2.5, and this is how we find. Now in the next problem sum, again we have an equation where the square value of x is given, and from that given equation we have to find the value of x. So in the first step what we will do, we will write that equation. Now what we can see here is, on the right side of that equation, both in the numerator and denominator we have decimal numbers. So in the next step what we have to do, we have to represent those decimal numbers by their equivalent rational numbers. Now if we further rearrange, then it can be written as 81 divided by 10 multiplied by 10 divided by 289, and the simplified form will be 81 upon 289. Now in the next step what we will do, we will represent the rational number that we have on the right side as a perfect square. So 81 and 289 first we will represent separately and then combinedly. So 81 we know that is a square of 9, and 289 is square of 17. So finally it can be represented as 9 divided by 17 and then square of that. And in the final step what we will do is, from x square the value of x we can easily determine, and that will be 9 divided by 17. Now in the next question we have to find the period of the given number, which we can see is a repeating number or recurring number. So here what are the digits that are getting repeated? 639, then again 639, then again 639, and these three digits are getting repeated. We know that the period of a recurring number is the digits which actually get repeated. So here 639 will be the period of the given number. Now in the next question we have to find the periodicity of the given number, and this is again a recurring number. And what are the digits here that are getting repeated? 639, then again 639, then again 639. But this time we have to find periodicity. And what is the periodicity? This is the total number of digits that get repeated. So here three numbers or three digits get repeated. So here the periodicity of the given number will be 3. Now in the next question we have to find the smallest positive irrational number. Now we know that irrational number is the number that we cannot represent as the ratio of P and Q, where Q is not equal to 0 definitely. And this time we have to find positive irrational number which is smallest. Now if we take the example of say root 2, we know root 2 is equal to 1.414, then 2135 and so on. This series of the digits that we have after decimal point or as a whole, this number never ends and the digits never recur as well. So this is actually an example of irrational number. Now if we take the square root value of this infinite decimal number that we have on the right side, then again it will be an irrational number. And if we take further the square root value of that number, then again it will be an irrational number. But definitely the value of the square root will be smaller than the value of the actual number. So this way we will keep on getting the smaller number or smaller irrational number. So we can never say where it will end, and it will never end actually. So we cannot find the smallest positive irrational number. So here the appropriate answer will be that we cannot define or we cannot find smallest positive irrational number. So it will be not defined or undefined. Now the next question says the sum of an integer and a proper fraction is what? We know that is actually mixed fraction. The next question says the decimal form of a proper fraction whose denominator is a multiple of 3 is what? We know that proper fraction is that fraction where the numerator is always less than the denominator. Now let's take an example, say 7 divided by 10. This is a proper fraction which we can represent as 0.7, which is a decimal number. Now again if we take another example, say 7 divided by 30, this is also a proper fraction. And how to represent that as a decimal number? So what we can see here is it can be, the denominator can be written as 7 upon then 3 multiplied by 10. So what we can say here is the denominator is actually multiple of 3, and that's what we have as the requirement in the question. So this can be further written as 7 divided by 10 and then multiplied by 1 divided by 3. 7 divided by 10 we already know that is 0.7, and 1 divided by 3 is what? 1 divided by 3 is actually 0.333. So this is a recurring number. This will become 0.2, then 333, and that will recur and that will end with 1. So this is basically a recurring number where 3 is getting repeated. So our answer for this question will be the decimal form of that number will be recurring in nature. The next problem says the non-repeating and non-terminating decimals are called what? So first of all, the decimal number is non-terminating. So it will never end. The digits after the decimal point will never end. At the same time, this is also non-repeating. And since this is non-repeating, so that decimal number can never be represented as P divided by Q or as a rational number. So this type of non-repeating and non-terminating decimals will be irrational numbers. So with this, I end today's class. Thank you.